Advanced Financial Modeling, Topic 2, Portfolio Optimization, Learning Objective Number 2. We are going to construct and graph optimal portfolios and efficient frontier using Excel Solver. So an efficient, risky portfolio is one that either maximizes expected return for a given volatility or minimizes volatility for a given mean return or portfolio return. A set of efficient portfolios is called an envelope or an efficient frontier. You find the efficient frontier by running Excel's solver, where you set an objective to say max return by setting vol to equal to some target and make sure all the weights add up to 100%. Or you minimize vol, set return to some targeted value, and also set weights to 100%. The optional constraint is also there's a box in Solver that you check if you want to ensure that the weights cannot be, have to be non-negative, in other words, only positive or zero weights. And you would do that if you want to specify you don't want any short sales, no negative weights. So we're going to run to or jump to our spreadsheet. And what we've done again so far is we have an equal weight portfolio. 100% of the money is invested. That portfolio has a portfolio mean of 7.5 and vol of 940. Notice these two value or cells have range names: mean, vol, and W sum. So mean is my portfolio mean, vol is my portfolio vol, W sum is the sum of all the weights, and remember this is still W, the vector of weights. So I'm going to run a solver that's going to minimize volatility for a particular rate of return, and we want to make sure there are no short sales, no negative weights. So I want to go back to my spreadsheet, and I've set up a set of portfolios efficient portfolios I want to create. I want to find the best portfolio that provides a 5% mean return or expected return, the best portfolio that provides the best 6, then 7, 8, 9, 9.5% return. Well, how I'll do that is I'll try to ask Solver to minimize volatility for a 5%, so minimize this cell here, 5%, or the standard deviation of the portfolio. Make sure this number is equal to 5. That's going to be one of my constraints. I want to, again, minimize standard deviation, set expected return equal to 5% by changing these weights and make sure all these sum up to 100 and none of these values can be negative. So I'm going to go to Data, Solver. I'm going to reset all. I want to minimize portfolio standard deviation and click on min by changing the weights. All the weights, D2 through D6. Add a constraint that the portfolio mean is equal to 0.05. That's just by definition. I've said find the best 5% mean portfolio. And I want to add a constraint that W sum is equal to 1. 100% of the money is invested. So notice it has changed those cell names to range names. I want to minimize vol by changing W, that's the vector of weights. The mean is equal to 5% and the sum is equal to 1%, and I'm going to leave this box checked, which is the default, makes unconstrained variables non-negative. In other words, you can only have 0 or positive. And then I'm going to solve. Make sure you read this. Solver found a solution, because you have to make sure it worked. Solver found a solution. Hit OK. So the best 5% mean portfolio gives me a vol of 183, and it's mostly money market. 83% money market, a little bit of bonds, a little bit of emerging market, no foreign equity, and a little bit of US equity. So what it's doing is looking at all the correlations and covariance terms to minimize that portfolio standard deviation for the 5% mean rate of return. So that is we'll call this an efficient portfolio. It is the minimizes ball for a 5% return. Notice I have a link down here. This is a link to the portfolio vol up here, portfolio mean, a weight of US equity, foreign equity, emerging market, and so on. Those are all the weights. I just have a link here to take that data and put it in one row. Because I want to do is I want to list 6 efficient portfolios. By the way, sometimes we call the collection of efficient portfolios the envelope. But instead of typing in this value, all these values again, I'm going to copy this, which happens to put everything exactly in this table format. I'm going to copy, come down here, Alt HVV, Alt HVV, Alt heavy, Victor, Victor. That'll paste special value. All Excel functions have corresponding letters that you could use for a kind of hotkeys in case you didn't have, in case you want to, do something without a mouse. And so there we go. This is the best 5% return portfolio. Let's find the best 6% return portfolio. Data solver. We can leave all the other constraints except where it says mean. I'm going to change and make that 6 and hit OK, solve. Solver found a solution. The best 6% portfolio. I'm starting to get a little more bonds, a little more stocks. I'm going to copy these values again. Control C, Alt HVV. Let's find the best 7% return portfolio. And notice I've already done these for you. And so let's just do solver one more time. Data analysis, solver. Change that to a 7% mean. Solve, found a solution. Copy, and Alt HVV, paste. So what you see down here, this is a set of 6 efficient portfolios. You can see as you demand higher rates of return, it's starting to invest in higher risk assets. So notice that if you want the best 9% return portfolio, it's 66% US equities, 25% emerging equities, and a little bit of bonds. And if you want the safe, the best 5% portfolio, it's mostly money market. So this is kind of a collection of efficient portfolios, a set of efficient portfolios. Now, what we want to do is we want to graph this. We want to graph the vols and the returns. So what I'm going to do is I'm going to select these 2 columns, and I'm going to insert an XY scatter graph. XY scatter with a line. And there's a graph. These are our assets. If I want to give this graph a particular theme, I can just pick one of these here. While I'm holding the graph, looks like chart design is up. I can take a look at this one or this one. Let's go ahead and use this black one for now. Or maybe we can find one that also has labels for the X and Y. Let me see if I can find a better one. Oh, that one's fine. We'll just pick this one. All right, we can call this the efficient frontier. Or envelope. My y-axis are going to be the portfolio means. And let me see here, back to chart design. Let's add an element, axis titles. That's vol. And that's mean return. All right, now we have portfolio. If you want to have each one of these give a label, well, what we can do is do a few things here. Once we have this graph set up, I'm gonna make it a little bit smaller. We could add the individual assets there to give you an idea how they compare. Let's just add one of these. Let's bring the graph back up here. Let's put an emerging market on this graph. So I'm going to do a right click on the graph, select data, and I'm going to add. I'm going to put in emerging market. The X is going to be the vol. The Y is going to be the emerging market mean. Hit OK. Oh, where'd that go? Let's look at this data. Let's look at this one more time. Select data. Emerging market, edit. Series name, emerging market. X value is 18%. Y value is 9.5. Hit OK. And it's this point right here. What if we want to put US equity on there? Select data. Add. US equity. Portfolio X value is the standard deviation. The Y value is going to be the expected return. OK. OK. And you can see that point there. So it's just adding individual points to the graph. You can then also add these labels if you want it. So you select layout, add to access labels. You can just select those. And so this is how we can create an envelope or an efficient frontier. Notice these two assets here are totally dominated by the envelope because I'd rather be here, this second portfolio on my envelope, than this asset here, which is a bond, because it has higher return and less risk. Now we can try to add that to our graph. Let's take a look and see where it shows up. Select data, add. We can add bond. X is my standard deviation. Y is my mean. Hit OK. OK. And again, you can see here that bonds are totally dominated by this envelope. In other words, no one would ever put all their money into bonds. They would rather have a portfolio that looks like the second portfolio, which is 22% bonds, 51% money market, 6% emerging market, and 20% equity, because it has lower risk than bonds and higher return than bonds. It's totally dominated by this efficient or envelope portfolio. So in this topic, we've talked about how to construct and graph optimal portfolios or efficient portfolios using Excel's solver. In the next one, we will add the risk-free borrowing rate and optimal levered portfolios to this set of portfolios.